Greetings, this is Mr. Caslin. We're going to talk today about a special factoring pattern called the sum or difference of cubes. Difference of cubes, that may sound familiar. You had something in Algebra 1 called the difference of squares. It looked like this, x squared minus 25. And when you were asked to factor it, there was a special factoring pattern. You took the square root of x squared, you got x. Took the square root of 25, you got 5. And remember to cancel out the middle terms. You'd have to have one, the binomials be a positive, one be a negative. So you had this factored into x plus 5, x minus 5. All right. So here we have something called, let's talk about the difference of cubes, where if this is a perfect cubed, and we're subtracting another perfect cubed. For example, if you take the cube root of 8x to the third, well, that's 2x. If you take the cube root of 125, 5 times 5 times 5 is 125. So the cube root of 125 is 5. Okay? The difference means they're subtracting them, so we have the difference of cubes. Now the difference is, no pun intended, the difference is you've got a more complicated factoring pattern now that you have to kind of memorize. Okay? And I'll explain what these a's and b's are in a minute. But notice the pattern going on here. If you have a perfect cube minus a perfect cube, we're going to factor that into, let's just talk about the variables a and b, and you have an a squared, a, b, and b squared. If you had the sum of cubes, you'd have the same pattern. You'd have an a and a b, a squared, a, b, b squared. You have to kind of memorize that little pattern going on there. It's not hard once you look at it enough. Okay, now the signs, if it's a difference of cubes, you're going to do, look at this little pattern I have. We're going to call this same, different, always positive. Okay, the sign, if this is a subtraction, we're going to do same, different, always positive. So it becomes a negative, positive, positive. If you have the sum of cubes, we're going to do, the sign is going to be same, different, always positive. It's positive, negative, positive. This will make more sense here in a minute when I show you an example. Okay, so let's do this example. 8x to the third minus 125. Remember, the purpose of factoring is to make this exponent as small as possible. So maybe we can reduce the exponents by factoring. So let's figure out in this problem what a is and what b is. Okay, remember I said you could take the cube root of 8x to the third. So we're going to call a 2x. Okay. Now we'll take the cubed root of 125, and we said that that was 5. Now don't worry about the sign. These are always going to be positive. The sign here is going to take care of itself in our factoring pattern. All right, so just a and b are always going to write those as positive expressions. Okay, now you're going to take your a and b and you're going to plug them into your formula. This is the difference of cubes, so we're going to use this pattern right here. Okay, so we have a minus b, so we would call this 2x minus 5. Okay, and we have a squared plus ab plus b squared. So a squared, now here's where mistakes are going to be made if you're not careful. When you're squaring a, square the whole thing. Make sure you're doing a 4x squared. Plus a times b. Okay, so plus a times b, so remember 2x times 5 is a 10x. And then b squared, you're squaring the 5, so plus 25. Okay, so 8x to the third minus 125 factors out into this binomial times a trinomial. It's helping us solve this equation because we're reducing the exponent. We had an x to the third, now we have an x squared. Okay, zero product property says that if we were solving this equation, to solve this for 0, you would add 5 divided by 2, so x is equal to 5 over 2, also known as 2.5. All right, now you had an x to the third, you boiled it down to an x squared. Okay, now you're going to solve this using any of the methods you learned to solve a quadratic. You're going to factor it. You could use quadratic formula, complete the square, any of those methods that you use there. Turns out this also factors into 2x minus 5 times 2x minus 5. I'm not going to show you that in this video, but you're factoring a quadratic trinomial. And it turns out that all of the solutions to this original problem are x is equal to 5 over 2. Now remember, when you can check solutions to polynomials by graphing them. So quickly, if we did 8x to the third minus 25, we would notice that it crosses the x-axis at 2.5, which is 5 over 2. Remember, x to the thirds can have possibly three real solutions. This one turns out to only have one real solution. So this is called the sum or difference of cubes. If we had a positive here, we did 8x to the third plus 125. The only difference is we would use the second formula down here. So hope this helps. You may need to go through this video a couple times to get through it all, but have a good day.